guys, good morning. Welcome to Aerospace Structure Lecture Series. Today we are going to see about the impact loading, basics and its fundamentals. So in introduction, impact load occurs when a force is applied suddenly over a short period of time. Let us take an example of aircraft is landing in a runway. The landing gear will take a short time period of load. This we'll take it as an impact load. It produces high stresses and strain compared to the static loading. Like the example, the hammer hitting the nail, car crash, and falling weights. The effect depends upon the force magnitude, impact velocity, and object mass. So the structure and material react definitely differently to impact and static load. So in impact load can cause both elastic and plastic deformation. Under impact loading, it crucial for safety critical design. So engineer must understand the material and the load, also the safety criteria while designing the components. So let us take the nature of the impact forces. It acts in millisecond, producing short spike in stresses. It transfers the high energy and rapidly throughout the little bit of time. The initial force magnitude is often much higher than the static load. It can include shock waves throughout the material and the real near surface or near atmosphere region. So in this, the atomic bomb or the missile hitting the target and getting the high impact and high shock wave throughout the material. This resulting stress depends upon the stiffness and the damping characteristics of the material. Energy can be absorb capability, which reduce peak force and the damage. So the energy absorption can reduce the damage a little bit. The engineer must design to handle both peak and the residual stress. Next, the impact loading comparing with the static loading. Static loading applied force slowly or allows in equilibrium, whereas in impact loading apply the force rapidly, causing the dynamic effect. This impact load includes high stresses than the static load for the same forces. So the difference is the structural response differs, oscillations and the shock effect are common between the static and the impact load. The design safety factors are higher for the impact scenario, so that the material under impact is often brittle or catastrophic failure. The impact analysis ensures design can handle both intended and accidental loads. So these are a few examples of impact and static load. The impact load in common scenario, the impact drops object impact floor or the platform, the reacting element. Car collision and crash worthiness test can be added in this example for the impact load in common cases. Hammering and forging and the metal forming process take place the same thing in the material. Sudden fall of construction metal on the supports or the building collapses due to the shock or the vibratory loads. The wind gust or debris hitting buildings during storm. Aircraft landing and the landing gear touches the runway or the down in the touchdown point. The spotting cracks like tackle with robbery or the footballs. These are the few scenarios we can think about the impact loading on aircraft, football, metal forming, wind gust, buildings, car, and so on. Next, coming to the basic formula for this impact stress is sigma equal to root of 2EH W by A, where E is modulus of velocity of the material, H is the height of the object which fall to make the impact. W is the weight of the impact object and A is the cross-sectional area of the impact object or material. This is a formula helps to understand the stress produced due to the impact load on the material. Next, the energy conversion due to the impact is to be analyzed by using the energy method. The potential energy of the falling mass converted to the strain energy U equal to mgh, that is half time load into change in dimension or the deflection. That is in the strain energy in equation. The material elastic deformation determines how energy is absorbed or dissipated. The plastic deformation absorbs more energy than the elastic deformation. Energy absorbed reduces the force felt by the structure. Understanding the energy flow in the key to designing crashworthiness system is the main thing we can understand from the energy conversion on impact by using this potential energy equation or strain energy equation. Few factors that are affecting the impact response. One is the metal property. Obviously, we'll understand the stiffness of different material and strength of the material and durability of the material makes the absorption of the energy. It will reduce the impact or the changes the impact of the material. Impact velocity. High velocity means high stress will produce. Shapes and contact surface are the one of another parameters which can be affecting the impact response. Structural supports and boundary conditions also the major thing in factors affecting due to the impact load. Mass and the geometry of the impacted body, and absorption and dissipation energy is a damping property. One that properties makes the absorption rate in different format like reducing or increasing rate. Temperature and the rare dependent metal behavior also the another impact. Coming to the ductile and brittle behavior under the impact, we know the stress strain curve. Here we have the impact on the temperature, brittle and ductile material. Ductile material deforms plastically and absorbs energy, whereas brittle material fractures within minimum deformation. Impact loads causes the unexpected brittle failure at low temperature, whereas the steel shows ductile to brittle transition depends on the temperature. We can test this in two methods. One is RP and ISAT testing methods where we can evaluate the metal toughness. So with this brittle fracture under different impact is usually sudden and dangerous. So ductility is preferred in design involving possibility in impact scenario so that we can avoid the large failure or large dangerous things. So let us take an example of impact loading on beam. We usually use this in aircraft wing or fuselage. Let us consider a beam under the impact experience dynamic bending. Peak stress can exist, static limit may limit times can be measured. These deflections large and the static condition for the same load and the natural frequency influence the response amplitude of the beam. This is the due to the proper support and the loading condition which may reduce or damping the impact damages. Designers should use both dynamic load factor and the strain energy concept while designing the beams like aircraft wings and fuselage. Next, coming to the impact loading in automotive design, crash test, simulation, real world collisions and impact are the primary thing in automobile engineers or automobile design consideration. Especially car frames are designed to deform in controlled manner so that it can be absorb the failure, whereas it cannot transfer the total load to the passenger or the driver. The crumpled zone absorbs energy to protect the passenger, especially the material selection which balance strength and ductility. Ice and steel, composites and aluminum alloys are the few common materials which are used in this crumple absorb zone. Sensors and the crash analysis predicts force distribution, where the impact resistant design is a key safety factor or compliance in the automotive design. Next, coming to the impact loading on structures, especially the building structure face the lot of accidental impact, the vehicle, machineries and earthquake, and so the reason. Design codes specify the impact resistant criteria for the safety of the buildings. Reinforced concrete and steel can handle high impact loads, whereas the shock absorbers and the isolators minimize the damage during oscillation or collision. Structural redundancy improves the impact resistance, resilience, and so on. Damping layers reduce the force transmission from one part to another, one metal to another, so that the energy can be absorbed and the failure can be reduced. Simulation tools like FEM predicts the impact effect of the structure, more or less the exact value or accuracy can be increased. Next, Impact testing method. We have the few methods in industry or the testing laboratories like Charpy testing, ISAR impact testing, drop testing, instrumental impact testing, high-speed camera which reveals these failures and material configuration are certified, what standardized of this material due to the impact test. Next, reason for impact resistance. Increase section modulus for the bending resistance like I section, T section. This can be increased in the bending resistance. Choosing material with high toughness and ductility so that the design for controlled failure instead of sudden fracture. Use energy absorbing structures, forms or crumble zone. So avoid the sharp corners to avoid the stress concentration. Using reinforcemental and additional supports so that it can be impact resistance one. We have to do the regular inspection to ensure the long-term impact safety of the structure. So here we have conclude or the summarize today's class. The impact loads are dynamic, sudden and often higher intensity one. So impact loads require different design approach for a static load and the impact load condition. Energy absorption is critical for minimizing damages. So material property is another one factor to ensures how much failures, how much prevention happen during various modes of failure. Safety factor must be introduced for impact scenario by using the energy absorbing material. Impact loading known as virtual in many industries like automotive industries, civil industries, aerospace industries, and so on. Thank you. We'll see you in the next class. Thank you.